Okay, good morning. This is Professor David J. De Los Reyes. Okay, it's October 26, 2023. The time is 5:25 a.m. Okay. My topic for this session will be the study of trigonometry, and this will now be the continuation of my long topic trigonometry, and we are now on lesson number 10. Okay, let's proceed. The subject matter for this morning will be trigonometry lesson number 10, and the title of the topic will be example problem on angle and distance. The title of the topic will be example problem on angle and distance. Distance meaning the computation of the so-called rectilinear motion. It is actually a motion in straight line and with the constant velocity. So it's a distance problem and angle problem. So this falls under the so-called study of or measurement of angles. But this is in relation to distance problem. So we add up a certain formula on how to bring out the angle required. Okay, I will try to read the example problem. This will now be the last example for this topic, because the next time around we will be having a new topic, and that is actually the study of right triangles. Study of right triangles is actually a very interesting one. It always comes out on the short videos. Okay, let's proceed. Starting from point A at 2 p.m., a ship headed east until it reached point C at midnight. Starting at point A, the initial time is at 2 p.m. A ship headed east. Headed east, if we try to bring out the so-called direction, that is, this will be north, this is south, this is west, and this is east. So if this is the initial location of the ship, it started at point A at 2 p.m. and headed east. Okay, we are following the east direction, headed east. Then it reached point C, and the time it arrived at point C is actually at 12 midnight. Okay. Then it turned north. Okay, upon reaching point C, it turned north, meaning if it says it turned north, supposedly the distance is actually perpendicular with the original direction. If it goes east on the first time, then it goes north, supposed to be this eastward and northward direction should be perpendicular with respect to each other. So the resulting figure should be a right triangle. Okay, I will try to continue. Then it turned north until it reached its destination point B at 7 p.m. That is a long time, right? From midnight to 7 p.m. If each speed between AC is 8 miles per hour and between C and B is 10 miles per hour, find angle CAB. Okay, so the requirement for the figure should be to draw our compass, right? Then we'll try to, what do you call this, graph the point of the ship's location at any given point in time. It is at point A, it is at 2 p.m. Point C, it's at midnight, and point B at 7 p.m. Okay, this is point A, the initial location. Okay, the next location will be point C, and the final location is point B. Okay, this is eastward, this is northward, and according to the given condition of the problem, the speed from A to C is 8 miles per hour, and the speed from C to B is 10 miles per hour. The problem is asking what will be the angle CAB. CAB, meaning this angle theta here. Okay? CAB or angle theta. The problem is just asking for the value of angle theta here. Theta. Right? That's why our topic is actually an example problem on angles plus distance problem. Okay, because what is being asked is an angle. So the contents of the topic is on an angle, a problem on angle problems plus a distance problem. I think we have placed already the correct figure. The initial location is at point A. The next location is at point C. And the final location is actually at point B. Okay, the total travel time from A to C, we could compute for that one. From 2 p.m. to 12 midnight, that's actually 10 hours if we try to bring out the solution. The required here is angle theta, right? That's why it's an angle problem and distance problem. So to bring out the solution, we must have to compute for the time first. We could compute for the time orally, right? From A to C, from 2 p.m. to 12 midnight. So if we count from 2 p.m. to 12 midnight, it's actually 10 hours. So small letter t with the subscript EC, meaning the time consumed from point A to point C is actually 10 hours. Okay. What's the next one? We need to compute for the time from point C to point B. At point C, it reaches point C at 12 midnight. Then it travels going to point B. Then it reaches point B at 7 p.m. So actually, that was a very long time. It's one complete revolution of the clock, which is 12 hours. Okay, plus 7 hours. So the total hours will be, total hours from C to B is almost, it's very near 24 hours. But it's not 24 hours. It's 12 plus 7, and that is actually 19 hours. Right? So it's a long journey. Small letter t with the subscript CB, meaning the time consumed from point C to point B is 19 hours. Okay? So how do we bring out the distance relation here? That's why I told you the title of the topic is example problem on angles and distance. So this will be in relation to distance problem. So to bring out that angle, we must have to use a certain formula that relates to a rectilinear motion, a motion in straight line, right? That is in general distance d. You could place it s, but I prefer here an algebra to be d. Distance d is actually rate, the constant rate or constant velocity multiplied by time. There's no acceleration. The speed is constant. Right? So using the equation, distance is equal to rate times time, or velocity times time, it's the same. If we try to compute for the total distance traveled from A to C, we could compute for that one, right? Because the rate from A to C is 8 miles per hour. Am I still on the camera? 8 miles per hour, right? And the total time is actually 10 hours. So using the formula, distance is equal to rate times time, or velocity times time. It's the same. Substituting value, this should be, the rate from A to C is 8 miles per hour. Right? And the total time is 10 hours. So this is 8 miles per hour times 10 hours. Okay? The operation on the numerator are all multiplication, right? So we can cancel something on the numerator and denominator. There will be no violation that as long as the operation is multiplication, right? So this hour here cancel with this hour. 8 times 10 will be 80. And the resulting unit of AC now, it should be a distance, right? So this is 80 miles. So meaning to say, from A to C, okay, The total distance traveled is 80 miles. This is 80. Right? From C to B, we can also compute for that one. It's still a distance problem. That is, distance CB will be equal to the speed going from C to B times the total time consumed. The speed is actually 10 miles per hour. 10 miles per hour times 19 hours. Again, the operation on the numerator is all multiplication. So we can cancel something on the numerator and denominator, and this hour here cancel with this. Okay, so 10 times 19 will be 190, and the unit should be miles. So meaning to say, from C to B, if the speed is 10 miles per hour and it consumes 19 hours, the total distance should be 190 miles. Right? So if we now try to compute for the angle CAB or angle theta, okay, it seems we are given a right triangle, right? This is eastward, this is northward, so supposed to be this direction here or this distance here is perpendicular for the northward direction. Okay, so this should be 90 degrees. So actually it seems we are given a right triangle in which the opposite side and the adjacent side, considering angle theta, are given. Considering angle theta, this is opposite side. Considering angle theta, this is adjacent side, the 80 miles. Okay, we can erase the speed now. We are talking distance now. This is 80 miles. This is 190 miles. This is angle theta. So with this 190 with respect to theta is opposite side, and this 80 miles with respect to theta is adjacent side. So if we try to compute for theta, we'll bring out one of the definition of the trigonometric functions. Out of the 6 trigonometric functions, the correct relation should be either tangent or cotangent, okay? So if we try to compute for the value of theta, we'll take the tangent of theta. The tangent of the unknown angle, okay, angle theta, should be equal to the opposite side over adjacent side. So this should be a 190 or CB or over AC. Or if we try to compute for theta, okay, there is a tangent theta on the left. So to eliminate tangent of theta, we get the arctangent to the minus 1 of both sides. Okay, take the arctangent of both sides. The arctangent of tangent of theta will be theta, and the arctangent of the ratio C over B will be the arctangent of the ratio CB over AC. So this is arctangent. CB is actually 190, AC is 80 miles, this is 80. 180 over, or 190 over 80 is 2.375. This is arctangent. The value here is greater than 1. Like what I said from our previous discussion of the values of a trigonometric function, if an angle is greater than, if the value of the ratio of the tangent function is greater than 1, the angle should be greater than 45 degrees. So if we try to bring out our calculator, if we press 2.375, press arctangent, what will come out will be 67.7 degrees. 67.16 degrees, it is greater than 45 degrees. So this is 67.16 degrees. Okay? Okay, that's it. So our example is actually an example problem that involves angles and distance problem. And for the angle, that is the last part of the solution. So to bring out this angle here, we must have to bring out a certain relation or certain values considering the distance value. Okay? Because we are given the spread from A to C, we are given the total time consumed, so we could compute for this distance. The speed from C to B we are given. we could compute for the total time, so still we could compute for the distance CB. And in the so-called definition of the trigonometric function, it actually involves distances, right? So this is miles, this is miles. So the proper relation should be tangent. Tangent of the single should be the ratio of the side opposite of adjacent in this case. Then to remove this tangent here, we take the arctangent of both sides. The arctangent of theta will be theta, and the arctangent of the ratio CB over AC is just the arctangent of CB over AC. And the answer will be 67.16 degrees. Okay, that's it. Good morning from Los Angeles. This is Professor David Gilles.